is a mixed practice of everything polygons we've done so far in the unit. The first four is dealing with angles. So you might need to refer to, it is after the sheet. It's the formulas that was on the sheet with the stop sign. Here it is. The stop sign and the birdhouse. Okay. So there was a table that has the formulas on it. And you're going to have to read the key information from the problem to identify which formula to use. That's for the first four. You will have to work backwards on a couple of them. So like on the first one, it says what's the measure of each interior angle of a regular 20-gon? So what formula should we use here? N minus 2 times 180 divided by n, because it says each interior angle. So that means one interior angle. Okay. Yeah. So on a problem like number 2, because they give you the sum of the interior being 1620, they want you to know how many sides. They want you to determine the number of sides. N minus 2 times 180 gives you the sum. Well, I know the sum equals 1620. So you're going to have to work backwards to solve this, meaning solving for n. Anyone know what might be a first step to get to that? Divide, get rid of this parentheses or this coefficient, divide both sides by 180 first. And then you have your n minus 2 equals, what is this? Isn't it 13? No. 9? Yeah. And then we're solving for n. On number 3 and 4, well, 3, like I said, correlates to the birdhouse on this same page. Sorry. We had, where's my birdhouse? Oh, here it is. We had the steps right here. And we had an example of the interior angle. So you always have to find the n minus 2 times 180 first, and then write your equation. So like I said, you might need to look at your notes to help you. Now, on number 4, I hope y'all see that these expressions are representing the angles on the outside. And so what do we need to know about the exterior angles? Yeah, they always equal 360. All right, okay. So that's what you're gonna use to set up your formula. Your equation to solve for x. Then we're back to what we've been doing, okay? Identifying the parts. I'm not really gonna stress 5 through 8. You just gotta read it off the diagram. There's not any computation on this section, okay? But then when we get to 9 and 10, this is where the green paper might help you. So on the first one, do we know the apothem? Yeah, the apothem from the center to the side here. So our apothem is 2 root 3. Okay, remember the apothem is perpendicular and it bisects the side. Okay, now, can we determine the perimeter? Yes, because they have given us the side, which is 12. So what would be our perimeter to our triangle?
27.
36, yeah. Okay, we just did 3 times the 12. All right, oops, sorry. All right, so to find the area, this is the formula when we do apothem times perimeter divided by 2. This is going to be a radical answer. Let me show you why. The apothem was the 2 root 3 The perimeter was the 36. And then we're taking those products and divide by 2. Well, I'm just going to simplify this because I can do the division of one of the factors. Like 2 divided by 2 is gone, right? So I'm left with just 36 root 3, excuse me. This is a radical answer. If you didn't simplify like that, and you just said, I'm going to multiply this 2 times this 36, okay? If you do that, that's 72 root 3, but then you still have to take half of that, and still going to give you the same answer, because half of 72 is 36, and then you leave your radical. You can't take half of radicals. You can only divide radicals by another radical, okay? All right, so on these first set of problems, you're going to be given the part so you can fill in the blank. But when you get to this page, which is, let's talk about number 13. Now, if you notice, the parts are not all filled in. Like you can't physically see the apothem. You're going to have to draw it. So you're going to have to draw the segment from the center down to the side. I know this is kind of crooked. And it has to be perpendicular. And it will bisect the side. Okay. And then you're going to also have to draw your radius so that you create the angle. So your central angle is just taking 360 divided by n. We have 6 sides. If I do 360 divided by 6, that means my central angle is 60. But for calculation purpose, you need the angle with the right triangle. So you have to take half of that 60, and that will give you the 30. So does everyone understand this 7 gets cut in half? Yeah. All right, so that means we have, oh, you have 6. Okay, let me fix that. So you have 6. Okay, so then that means this is 3 and 3. All right, so then the apothem, does anyone know what the apothem is going to be now? Yep, 3 radical 3. Okay. So now, since I know my side is 6, my perimeter, we just do 6 times that, which is 36. So to get the area, you're taking the apothem times the perimeter divided by 2. Our apothem is the 3 root 3 times the perimeter, 36, divided by 2. This is also a radical answer. Okay. So I would strongly, when you get to pretty much 10 and on, or 11 on, you might need to refer to the green paper where you, especially example 1, where it tells you find your central angle, then take it and cut it in half, because you're gonna have to draw right triangles using your apothem. Like on 14, the 5 root 3 is your apothem. This angle in here turns into a 45, 90 triangle. This would also be 5 root 2. So the whole side is 10 root 2. Okay. The perimeter would be 40 root 2. So now you're just plugging into the formula. This will turn into a whole number answer because you're multiplying radicals that are the same. All right. Then when we get here, it says you're going to use trig to help you problem solve to find the area, because our central angle here, that's the 360 divided by 5, which was 72. We're going to take half of that, which gives us the 36. Now you're using trig ratio, the trig equation, to find the apothem. You need the apothem to get to your area, but we also need We also need to find, and I'm going to make a marking here, we need to find the x, because we need that to find the perimeter. If I use my hypotenuse and the plot them with that angle, do you know what trig function you're dealing? Yeah, because you have the adjacent and you have the hypotenuse. So we're doing cosine of 36 equals a over 8.5. Then you want to either use Pythagorean theorem or use trig again to find x. You're going to have to do 2 calculations before you can even get to the formula. Okay, these are going to require multiple steps. I'm just giving you a heads up. Okay, to the nearest tenth, yeah, round to your nearest tenth. I don't think I have my calculator up. So yeah, the variable's on top here, so that means we're multiplying to get to that answer. So it should be 8.5 times the cosine of 36. Okay. Now that's the A, but you're gonna need to also find your X. So this is 6.9, okay? That's your A. Okay, we're gonna also need to find the X. So I can either do trig again, because this part would be the opposite part. So I could say sine of 36 equals x over 8.5. Or I can do Pythagorean theorem. It's up to you, okay? But you're going to do 2 calculations per problem. Okay? And then now that you have x, you can double it to get to your side. And then now you can get to your perimeter. Okay? Yeah, this rounds to 5. Okay, so that means our side is what? 10. There we go. So because our side, I'll put it up here, is 10, then my perimeter is 50. Now I have my pieces to plug into the formula. You will have decimal answers here. All right. All right. This will be due before you leave class tomorrow. When you have a special rate, if you have